Before we tune in on the air conditioning lesson Art is about to give Jack, I want you fellas out there who get duck bumps just thinking about air conditioning service to quit squirming in your seats. Take my word for it, every one of you master technicians can handle air conditioning service right now. All you have to do is follow the instructions in the service manual. Of course, I'll have to admit, following a step-by-step troubleshooting procedure without a working knowledge of refrigeration is sort of like being led across a busy street blindfolded. You'd feel a lot more confident if you knew what was going on for yourself. What do you say, Art?
I couldn't agree more, Tech. Matter of fact, I was just telling Jack here that understanding a bit about refrigeration so you aren't afraid to tackle air conditioning service is half the battle. Besides, a working knowledge of refrigeration helps you spot trouble faster.
Besides, understanding how refrigeration units work will help you run and evaluate the diagnosis tests, including a new one Art will tell you about a bit later. Right now, give Art a chance to take it from the beginning, starting with controls and inspections. Then, after a review of refrigerants and refrigeration, you'll be ready for a lesson on tests and diagnosis.
Okay, I'm listening.
The preliminary tests and inspections are mighty important. They'll usually tell you whether the trouble is air circulation, temperature control, or refrigeration. On every air conditioning complaint, run the system and test the controls. Make sure that every door is opening and closing at the right time. The push-button control charts give you all the dope you need to test these controls. Under the hood, the compressor drive belts must be properly adjusted and not slipping. Also, there must be no clutch slippage under load. While you're at it, inspect the condenser fins. They should be open and clean. In other words, no restriction to airflow to or through the condenser. Incidentally, bug screens do restrict airflow and shouldn't be used on air-conditioned jobs. With a heavy heat load on the evaporator, the sight glass should show a solid stream of liquid refrigerant. A steady stream of foam means low refrigerant. And whatever you do, make sure there's no water flow through the heater core when the controls are set for maximum cooling. Just a word of warning, remove the radiator cap to relieve cooling system pressure before you pull that heater hose.
Hey, all these inspections and tests sound awfully elementary. When are you going to get into the refrigeration part of the system?
Quit sounding like a parts changer, Jack. The only thing worse than being afraid to tackle air conditioning service is jumping into the refrigeration system without finding out whether the trouble might be something simple, like controls or a hot heater core. You know, I'd be willing to bet that on half the air conditioning complaints, there's absolutely nothing wrong with the refrigeration part of the system. How about it, Art?
That's been my experience, Tech.
Okay. I promise to always test first things first. Now, will you give me that lesson in refrigeration?
That's exactly what I was about to do, starting with a word about cooling by evaporation. If you put a small amount of alcohol in the palm of your hand, it's cooled by the process of evaporation. Heat from your hand flows into the alcohol as it changes into vapor. The alcohol is the refrigerant. Now, if you put some refrigerant 12 in the palm of your hand, it would vaporize so fast you'd have a frozen spot on your hand in a matter of seconds.
Let that be a lesson to you. Don't spill or splash liquid refrigerant around.
I'll be careful. What's next, Art?
In a refrigeration system, liquid refrigerant evaporates and absorbs heat. The refrigerant vapor is compressed, then condensed into liquid so it can be used over and over again. The evaporator is nothing more than a chamber where the liquid refrigerant can soak up heat and change into gas without being lost.
And here's an important point to remember. It's the evaporating liquid refrigerant that removes the heat. The liquid soaks up heat only when it has room to evaporate or expand into a gas. And that brings us to the expansion valve.
Right, Tech. The expansion valve meters liquid refrigerant into the evaporator just fast enough to ensure maximum cooling. If we didn't meter the refrigerant, the evaporator would be flooded with liquid. There wouldn't be enough room for evaporation, so cooling would be less than maximum. On the other hand, we can't just use a fixed orifice, because the evaporator would often be starved. It wouldn't get enough liquid refrigerant, so there wouldn't be continuous evaporation. Again, cooling would be less than maximum. If everything is working right, the expansion valve feeds just enough liquid for continuous evaporation and cooling from the inlet to the outlet end of the evaporator. That means a bit of liquid is left for cooling near the outlet of the evaporator, but there's no liquid leaving the evaporator, just gas. The compressor squeezes the gas and packs the gas molecules closer together. This increases the pressure and concentrates the heat so the gas gets even hotter. In fact, it gets so hot, even on a hot day, air flowing through the condenser fins picks up heat from the much hotter refrigerant gas. Cooling the gas changes it back into liquid refrigerant. Liquid refrigerant from the condenser passes through the receiver dryer strainer on its way to the expansion valve. At the expansion valve, the refrigeration cycle starts all over again.
Well, isn't there more to it than that?
Just a mite more, Jack. If the expansion valve controlled the temperature, the evaporator would get too cold and end up like a deep freeze that needs defrosting. There are several ways to prevent this. One way to control evaporator temperature is to stop the refrigeration cycle by stopping the compressor before the evaporator starts to frost up. Care to explain how that works, Art?
You bet, Tech. All Mopar cool air units have an electrical thermal switch in the evaporator. The switch is calibrated so it opens before the evaporator gets cold enough to frost. The thermal switch controls the magnetic clutch circuit. In other words, the system cycles on the clutch.
How is evaporator temperature controlled on this job?
The compressor has a built-in evaporator pressure regulator valve, or EPR valve, to control evaporator temperature. Here's how it works. The EPR valve controls evaporator temperature by controlling evaporator pressure. When the evaporator is relatively warm, gas pressure opens the EPR valve, allowing full flow to the compressor. When the evaporator gets cold, pressure gets lower. Lower pressure causes the EPR valve to reduce gas flow to the compressor. Reduced gas flow to the compressor reduces the load on the compressor, and it loafs along doing very little work. In other words, when the EPR valve reduces gas flow, refrigeration is also reduced.
You know, I think I'm beginning to understand this refrigeration business. Learning a few basic facts about the behavior of the refrigerant helped clear up a lot of questions. Now, can you explain these test gauges and valves for me?
Sure, Jack. The center gauge is always connected to measure pressure at the outlet of the compressor. This is actually head pressure. The manuals call it discharge pressure. When this valve below the gauge is closed, the gauge is connected to the test hose only. When you open the valve, the center manifold outlet, the gauge, and the test hose are all interconnected. The needle valve is there to put a restriction between the hose and gauge. You adjust it to damp out gauge oscillation so you can get an accurate reading.
Hold it a minute, Art. Someone better turn the record so we can hear the rest of Art's story about gauges. Now that you've caught your breath, how about explaining the rest of these gauges, Art?
Gee, thanks, Tech. The gauge on the left is called the suction gauge. This gauge is connected to the inlet side of the EPR valve. It measures the pressure of the refrigerant gas leaving the evaporator and entering the EPR valve. The suction gauge also has a valve-controlled connection to the center manifold outlet. With the valve open, the gauge, hose, and manifold are connected. With the valve closed, the hose is connected to the gauge only. The right-hand gauge is the compressor inlet gauge. This gauge measures pressure at the EPR valve outlet, which is the compressor inlet. Incidentally, this is a rod, not a tube. It's simply used to hang the gauge onto the set for convenience. You don't use this gauge on Mopar cool air units because they don't have an EPR valve. On Mopar cool air units, the evaporator outlet is connected to the compressor inlet, so the suction gauge pressure is also compressor inlet pressure.
Okay, I understand the gauges and valves. Now, how do you use them?
One of the first things I do is hook up the gauge set and check system pressures. Next, I start the engine and let it run for about 15 minutes to normalize the system. While the engine's running, get the preliminary tests and inspections out of the way. Controls, compressor clutch, condenser, sight glass, and heater water flow valve.
How about the performance test?
If you have marginal cooling, you'll have to run the performance test to see if the problem is humidity or refrigeration system trouble. On the other hand, if you're absolutely sure the system's not cooling enough and the problem isn't high humidity, you can skip the performance test.
Well, just why does humidity affect cooling so much, Art?
In real simple terms, Jack, moist air has more heat units to be removed than dry air. This means a lot of the cooling capacity is used up taking the water out of the air.
So, if humidity is high, you can't expect the air being discharged into the passenger compartment to be as cool as on a dry day.
Yeah, that clears that up. But one other thing bothers me. Why do we need a psychrometer to test the humidity? You get it in every weather report.
Yeah. And if you want to drive the car out to the airport where they take the relative humidity and test it there, you don't need a psychrometer.
Jack's right, Jack. You can't test performance accurately unless you can measure the humidity of the air going into the evaporator. This can be a lot different from the weather report.
Well, let's spare Jack any more embarrassment by going on to the EPR valve test, Art.
With pleasure, Tech. To test the EPR valve, we use the suction gauge and the compressor inlet gauge. The two gauges tell you if there's a pressure difference across the EPR valve. If there is, the valve is regulating. If the pressures are nearly the same, the valve is wide open. Remember that the EPR valve should be open when the evaporator is warm and calls for full refrigerant flow to the compressor. When the evaporator is cold, the EPR valve should regulate, in other words, reduce flow.
I'm with you. So to test the valve, we have to create the two different operating conditions.
That's exactly right, Jack. For the first part of the test, we must warm the evaporator. Open the hood so engine compartment heat is drawn in through the cowl vent. Open the windows to allow maximum airflow and set the controls for highest blower speed with fresh air cooling. This puts such a heat load on the evaporator that it just can't get too cold. Warming the evaporator causes suction pressure to increase. If the EPR valve is working right then, it is wide open. With the EPR valve open, compressor inlet pressure is 2 to 5 pounds less than suction pressure. This is because of the pressure drop through the valve. If the pressure difference is more than 5 pounds, the valve isn't opening fully. Now, to find out whether the EPR valve will control minimum temperature, we take the heat load off the evaporator. We do this by changing to recirculating air and lower blower speed, and we close the windows. As the car interior cools, the evaporator cools too. Suction pressure decreases, and the EPR valve starts to regulate. This makes the compressor inlet gauge oscillate as the EPR valve opens and closes. The important thing we're checking now is whether the EPR valve will back up pressure in the evaporator so it can't get too cold, and we have to wait until both gauges settle down. Then, no matter how low the compressor inlet gauge reads, the suction pressure must be at least 22 pounds. With 22 pounds or more back pressure in the evaporator, it won't get too cold.
That looks easy enough, Art. Is the compressor capacity test next?
Here's where we use a new test for the compressor and expansion valve, Jack. This is the simplest test yet. All we have to do is measure pressure and temperature at the compressor outlet and compare them with chart values.
Sounds good. How does it work?
The new test is based on the fact that there's a definite relationship between the temperature and pressure of the refrigerant gas in the system when the expansion valve and compressor are okay. You use the compressor discharge gauge and a thermometer clipped to the discharge line for the test. For any discharge pressure reading, the temperature should be in the range given in the table.
Here's an example, Jack. If the discharge pressure is 200 pounds and the thermometer reads between 172 and 218 degrees, the expansion valve and compressor are good.
I'll buy that for a minute. But tell me what can happen to get the temperature out of the range.
All right, let's take the expansion valve first. If it's flooding the evaporator, there'll be cooling right up to the compressor, so the gas temperature will be low with respect to pressure. But if the expansion valve starves the evaporator, the refrigerant gas becomes overheated. Then temperature is high with respect to pressure.
Well, that's reasonable. But where does the compressor come in?
If the compressor has bad valves or a leaking gasket, pressure is lost. Also, if refrigerant recirculates in the compressor, it takes on more heat, so the temperature would check high with respect to pressure.
Hey, wait a minute. That's the same thing that happens if the expansion valve starves the evaporator. What's the deal?
That's the only situation where this test isn't conclusive, Jack. If temperature is high with respect to pressure, you'll have to discharge the system and test the compressor and expansion valve separately as outlined in the service manuals.
Take my word for it, Jack. This new test will save a lot of time. More often than not, you won't have to make the compressor and expansion valve test.
Okay, Tech. See if I've got it straight now. For example, if the pressure is 200 pounds and the temperature is below 172 degrees, the expansion valve is flooding and should be replaced. If pressure is 200 pounds and the temperature is in the range of 172 and 218, the expansion valve and compressor are good. If the temperature is above 218 degrees, we have to test the compressor and the expansion valve separately, right?
Right you are, Jack. Now, before we end this session, let Art give you a couple of tips about that thermometer hookup.
Be sure there's tight contact between the clips and lines and between the clips and bulbs. The loop has to cover the thermometer bulb because if any of the bulb hangs out, you'll measure air temperature instead of refrigerant temperature.
And you'd better wrap that bulb and clip to insulate them from the surrounding air.
Okay, Tech, I'll do just that. Anything else I should know?
Everything else you and the other master technicians need to know about this new test is in the reference book, Jack. There's also more detailed information on everything we talked about today. In fact, this book ought to help anyone who can read, handle a wrench, and use his thinker service our air conditioning systems. And never forget, the customer who pays for this most costly of options expects it to work right. And if it doesn't work right, he expects you master technicians to fix it. So study this new reference book and use it. You too can be an air conditioning expert.